Hi, I'll be showing you the review for test 1 problems, and today in this video I'll be looking at bootstrapping questions 1 through 5. So to start, we should load the CSV file, and to do that we run the table command, and we have to read table and then the file name. And then we need to display 3 lines, 3 rows of the table. So we use the show command with 3. And here we have the table, and you can see trip ID, duration, and start terminal are the important numbers for us. Some of these rows start at terminal 70, and let's try to figure out how many trips there are. I'll pause for a moment here, and you can try the question on your own, and then I'll give the answer. Okay, so let's first filter the trip table so that we're just looking at rows where the start terminal is equal to 70, and we can use R equal to 70 here. And it's a good idea maybe to look at that table and see what we get. And here you have a nice table with 3 things, and what we really want is the number of rows, and there's 26,304 such trips. Okay, so now we'll imagine that we only have a random sample of 800 such trips. Let's try to gather such trips. And we're going to do that by sampling 800 trips starting at station 700 without replacement. So the way to do that is to start with the station 70 table, and then we're going to sample, and we want to sample 800 trips, and we want with replacement, which is the option, to be equal to false, because we're not going to be replacing trips. So that means we go in and we grab 800 different rows from this, and then we want to compute the mean duration of our sample. That should be NP mean of station 70S. Station 70S is a table. It's got 800 rows. We want to look at the column of that table that has the durations in it. Now, station 70S column duration is an array, and we're calculating its mean. 819.13. Okay. You might get a slightly different answer because you're sampling a different collection of 800 rows. Okay, so now we want to use bootstrapping to produce a histogram of resampled means from station 70S. And so we've got 800 rows here, and we're going to resample with replacement 500 times. So resampling with replacement means go back into this sample of 800 rows, grab 800 of these, but this time with replacement. So some of these 800 rows get picked twice, some of them don't get picked at all. Okay, so let's do this. First, I'm going to make an array called array of 500, and it's an empty array where I'm going to store the 500 means, and then I'm going to run a loop 500 times for I in NPA range 500. So NPA range starts at 0 and goes up to 499, and from 0 to 499, because we're starting at 0, there's 500 numbers. So we're going to go through this loop 500 times. And what we're going to do is calculate a resample. Let's give it the name resample. And we're taking station 70S, we're sampling If you don't give a number, it samples the same number of times as the number of rows, and here with replacement with true. And then let's call this thing mean value. It'll be the NP mean for this resample, but we're looking at the duration column. And then I've got this mean value. Now I have to add it into my array of 500 by using the np append command. Okay, now we've got this array. Let's make a table of 500. Let's call it. We're going to make an empty table, and then we'll add a column, maybe statistics, and we'll put the 500 statistics that we've calculated, 500 means. Then we make a histogram out of our table. We use the statistics column, and we'll use the bins equal to, well, let's see, NPA range. They start at 600, they end after 1300, and they go up by 10 each time. And this can take a moment to do, but there's our histogram. You again may get a slightly different histogram because you know, of the randomness. Okay, use your simulated values to compute a 95% and a 99% confidence interval. Well, to compute a 95% confidence interval, what we'll be doing is using our array of 500, so NP percentile of array of 500, and then we'll, a 95% confidence interval is missing 5%, right? And that gets split into 2.5% on either side, and so we'll calculate a 2.5 percentile and a also the 2.5 percentile, and on the top end is the 97.5 percentile. We'll calculate that, and let's call this the left 95, and let's call this right 95, and then let's write our confidence interval 95 to be left 95 and right 95. And similarly, we can do the same thing for the 99% confidence interval. Oops. Let's just change these. And this time we have 1% missing. That's 0.5% on either side, like this. And then we have to print them. There's the 95% confidence interval, and there's the 99% confidence interval. And the 99% confidence interval is wider than the 95% confidence interval, and that should make sense. If we're, in order to be more confident that our interval will contain the true mean, we're going to have a wider interval.